Okay, so with this equation, what we are going to be doing is graphing y equals 4x squared plus 8x plus 5. We need to recognize that this equation is given in standard form. So the standard form formula is y equals ax squared plus bx plus c. And you'll notice if I compare these, a, b, and c are these numbers right here. So with this particular formula, we have, or with this form, standard form, we have a formula for the x value of the vertex. So if we were going to graph this, we would want to have the graph, but what we want to find is the x value of that vertex, because that's going to give us the minimum or the maximum, the x value of it, right, on our parabola. So the formula is negative b over 2a. And you notice I have a, that's the 4 that you see here, right? That's a. And I have b right here, that's 8. So if I plug those two in, I'm going to get the x value of the maximum or the minimum of this graph. Now, if I look at a is positive, so we're talking about a minimum anyway. This graph is not flipped down. There's no negative there. So we are going to have a minimum, and we will be finding the x value of the minimum. In addition, this will also give us the x value of the line of symmetry. So let's go ahead and do that so that you can see what I'm talking about. So first off, I'm going to go ahead and plug in the 4 and the 8 for a and b, and that's going to look like x equals a negative 8 over 2 times 4. 4 times 2 is 8, so this is going to become negative 8 over 8. And anything over itself is 1, and of course it's negative, so that's going to be negative 1. And of course you could put that in your calculator if you needed to. But that is going to be the x value of my vertex. So I know that there's a line of symmetry at x equals negative 1 right here. And on that line, my vertex is going to lie. But we need to know the y value of the vertex. And so the way we're going to figure that out is we're going to take this number for negative 1, and we're going to take it and we're going to plug it back into our x value for our formula to get our y. So let's do that. So y is going to equal, and instead of x, I'm plugging in negative 1. So it's 4 times negative 1 squared plus 8 times negative 1 plus 5. So if I'm solving that, negative 1 squared is going to be 1. And 4 times 1 is 4. And then 8 times negative 1 is negative 8. And then plus 5. So if I add 4 and 5 together, that's 9. And 9 minus 8 is 1. So y is equal to 1. So what I have now is my vertex. X is negative 1 and y is 1. So if I go and I graph that point on my graph, it's right here. I know without having any more points at this point that this parabola is going to probably look something like this. That's not perfect. They're not the exact points, but just if I had to sketch an idea what I think it might look like, it would probably look something like that. If I want to find the exact points, at this point I could make a table. So in my table, I would have x and y. And my y would come from this equation, 4x squared plus 8x plus 5. And what I would want to do is I would want to look down this line of symmetry. Remember, this is supposed to be symmetrical. So honestly, if I really sketched a little bit better, it would probably look something more like this, right? A little more symmetrical. And this may or may not be the right sketch. We're going to find out. But what I would want to do is, since this is a line of symmetry, I would want to take a point on either side. So if this is at x equals negative 1, I'm going to use 0 and I'm going to use negative 1 to get my other 2 points. So if I put in x is negative 1 and x is 0, let's see what these become. So what is y when x is negative 1? Or I'm sorry, let me back up. That's not negative 1. The vertex is at negative 1. I misspoke. The vertex is at -1, so I want to take a point to the left of it. So I want to do -2, not -1. So I'm going to change that real quick, -2. And then, all right, so I'm going to plug this in. I need to find out what is y when x is -2. So this is what this looks like. I'm going to put in -2 everywhere there's an x. And then I'm going to go ahead and solve this. So -2 squared would be 4. 4 times 4 is 16. And then 8 times -2 is -16. And then I have plus 5. So 16 minus 16 is 0, and I'm left with 5. So the point is -2, 5. So this is one of my points, right? Oop, that was supposed to be a highlighter. This is one of my points right here. And then I'm also going to find when x is 0, what I get. So y equals 4 times 0 squared plus 8 times 0 plus 5. Well, when I do that, I get y equals 0 squared times 0 is 0, plus 8 times 0 is 0, plus 5. So what I'm finding is that, again, if it's 0, I get 5. So that's my second point. So I'm going to go ahead and graph these. So at -2, which is right here, it goes to 5. Oh, so my sketch was way off, right? So I'm going to get rid of my little sketch. All right, so put my vertex back in there where it was. All right, so -2, 5 was the first one, and then the other one was 0, 5. So, oops, I think I got rid of my blue vertex here. Let me put it back. It was -1, 1. There was my vertex. And then it was -2, 5. And then now I have 0, 5, which is right here. All right, so now I have 3 points, and what's going to happen is my parabola is going to look something like this. Okay, it's not perfect, but it goes through 3 points. And this is what our graph for y equals 4x squared plus 8x plus 5 looks like. So just to recap, you had 3 parts to this. The first part, find the line of symmetry and the x value of the vertex. That's what this was right here. And if I wanted to kind of box that off, this is where it would get boxed off at. Okay? Then the second part of this was to find the y value of the vertex. And so I want to box that off. It's going to look something like this. And that gave me the vertex when I did this. So that's part 2. That's not the best little, let's see if I can. There we go, part 2. And then finally, part 3 was making a table and getting 2 more points, one on either side of the vertex. And that's what I did right here. Okay, so if you're going back through this, steps 1, 2, and 3. All right, have a great day.